Hi there, this is Pinal Dave, and today we are going to talk about one of the very interesting topic about an index reducing performance of select statement. Now, hold on over here. You might have heard that index reduces performance of insert, update and delete. Well, there is no disagreement over here. I totally agree with you on this topic, but I'm going to take it a little bit forward and going to show you how an index also reduces performance of the select statement. Now, if nobody has ever told you this, don't worry about it. Most probably they do not know about this thing. And if you have ever attended any of my training, you probably know the reason why this is happening as well. But today, our goal is to explain you and show you how an index reduces performance of select statement. I would like to take this statement a little bit more forward and also tell you that index, even though it's not used for a query, it can reduce performance of queries, and even though they are select statement. Let's see a demonstration and you will believe it yourself. Now, here we are in SQL Server Management Studio. If you are a subscriber of my newsletter, at this location, I'm very sure that you know the answer of this query and you can just stop this demonstration right here. But if you do not know the answer, let's see this right away. First of all, I'm going to show you a query, and here is the query. I have enabled the statistics over here, and I have also enabled real execution plan. Now I will go with an execute statement, and we will have an execution plan over here. Well, execution plan always like to lie, so I would not spend time into this one, and I will directly jump to messages. Over here we can see two different tables: table sales order detail and work table. For sales order detail table, we can see the logical read of 1246 pages. If you are wondering what is 1246 pages means, well, that means each page is of size 8K. That means we will take 1248 and multiply that with 8, and this is the size of how much data SQL Server has to read from sales order detail. That comes out to around 10 megabytes. Well, that's good. So pretty much we are retrieving 10 megabytes of data from this table. Now, what is this work table? Well, this is actually use of temporary table. Now, we are actually reading logical reads of 368495. That comes out to be, let's see how much data it is. So here is the data. I multiply that with 8 and that's the answer. Well, this is a huge number. So I will divide that by 1024 and here is the megabyte here we have. Now divide that by with 1024 one more time and you can see this is approximately 2.8 gigabytes of data. That means to read SQL Server only 10 megabytes of data, it has to read around 3 gigabytes of data from TempDB. That's huge actually. That's a lot of data it is reading, and that's where you are losing performance. Let's fix this by creating a index. But a lot of people will say, why don't you create a statistics on the top of it? So here you go. I'm just updating statistics. After updating statistics, when I run the same query one more time, you can see in the messages there is absolutely no difference. So, well, statistics was not the issue. So there you go. Now, I'll create index on this table on two of the columns. One of them is sales order ID and second one is product ID. Now, once I create the index, just hold on. What happens, we will see. Now, we will go and run this query one more time and check the execution plan. Over here, you can see SQL Server is doing two scans. So if you are thinking traditionally, you would think this is very bad because there are two scans. One is on IX first try and second one is also on IX first try. Yep, there are two scans. Instead of one, we have two scans. However, when we go and check the messages, over here we can see logical reads are reduced to 612 and there is no work table. Technically, we improve the performance of this query by multifold. SQL Server does not have to read those 3 gigabytes of data to just read data from sales order detail. This is good actually, isn't it? Now I will create a second index which I will call a second try, and just so you guys know, only difference between this index is the order of these two columns. Over here sales order ID is first and product ID is second, and over here the order of these two columns are reversed. So you can see product ID is now first and sales order ID is second. That's the only difference I have. Now I run this query, and if you guys want, I can clear the cache, but really clear the cache is not gonna do matter, so I will not execute this and will continue to my query one more time. And over here we can see the execution plan is now very similar to before, and query first try, the scan has been restored once. So IX first try is now only scan once, and that's good, isn't it? But when we go and check the messages, woohoo, logical reads have been restored. So you can see logical reads are huge, and work table is back. That means temporary tables usage is back. Sales order detail is again reading some data, is lesser data, but logical reads are huge. So technically this query is super bad. So you can see, even though my index, this was not used in this query, it still reduces the performance. Well, if you don't believe me, hold on over here. I'm gonna do one more thing. I'm gonna drop the second try index. I'll drop the second try index, and let's run this query one more time and see what happens. At this point of time, you can see once again we are getting original performance back, and execution plan is definitely changed. Now this is the logical read, isn't it? At 612, which is good. But as soon as I create the second try index, let's see what happens. I create second try index, I'll run the same query again, and here we go, messages. Whoa, we have bad performance. And if you guys see the execution plan, definitely there is no mention of second try. But you know what? For all of you perfectionists sitting outside, I'm going to provide index hint. Look at that. Now I'm going to provide an index hint over here, and I will explicitly say we will use only first try index. That's it. There is no second try index over here. Well, let's see this, and now you can see in my execution plan, definitely we have made sure that we only use the first try index. You can see over here, you can see over here where my mouse is, and definitely in execution plan, only once this first try is used, and it's still reducing the performance of the query. Now, to prove that this was definitely the cause, I'll drop the second try index, and here we go again, and you will see a good performance back. Here it is, and execution plan once again changed. So yep, query hint, even though I specified to just make sure that my second try index is not used, it's still reducing the performance. So I just creating this index, just so now you guys are clear with what I'm saying. I just created this index. I just created this index. And by just creating this index, my query is losing the performance. Yep, that's true. It is. Look at that. It's so bad over here. There you go. So, you know, guys, this is extremely serious, but people don't talk about it. One of the most serious thing we have seen. If your index, and if you're not using this one, you must drop it, because an index, you have no idea, it can reduce the performance of other queries. So if you have index which is not used, and you are like, whoa, I just like, okay, that index is there, go ahead and drop that index, because that index can be just sitting there and reducing the performance of other queries. That can possible, that can happen. That's matter of the fact is happening in your system right now. You must be very careful when you create a new index. When you create a new index, you may think you are just creating that index to improve the performance of this query, but that very index can slow down all your other indexes, and that can happen as well. So you need to be very careful. Now, if you have a question why this is happening, how you can create a good index which is just good for your query, how you can create index and measure the performance of it with other queries. How do you rank one index over other index, and what you can do to create an optimal index? Well, that's like a consultant, isn't it? I actually like to teach this thing in my course, SQL Server Performance Tuning Practical Workshop for Everyone, where I answer you precisely these questions. So this workshop is recorded. If you want, you can just sign up for this one, and where I tell you all my business secrets. It's 100% demonstration oriented, like demonstration which you have seen. Exactly like that. It's a fast pace. There is absolutely no PowerPoint there, and it teaches you every single thing I know about SQL Server Performance Tuning or what I do at my customer. I share all my scripts, I share all my secret keys, and I also make sure that I unlock your abilities to do SQL Server Performance Tuning. This is not a usual performance tuning class which goes for hours and hours. Yeah, go ahead, sign up for the course if you're interested. The link is just right there in the description or on the blog post which you are reading. And yes, one more thing. If after you watch this course and if you still have any question for performance tuning, you know what? We can have 1 hour one-on-one mentoring session where I can just talk to you or your teammate. Get your team in this 1 hour session and ask me any question related to SQL Server Performance Tuning, and I would be happy to answer you. But one thing I promise, that after watching this course, your mind will start thinking in the direction which you have not thought about it. I would explain you 3 secret rules of performance tuning which you have never learned before from anybody else. And there you go. Talk to you soon with another demonstration in the future.